On today's episode, I'm joined by Jayden and Miles and special guest Jeff Siewert. Today's topic is a technical deep dive into muzzle tuners. Now, muzzle tuners are nothing new, but in the last few years, we've seen a huge popularity increase for their use in precision rifle sports. This podcast gets pretty into the weeds and is very technically dense, but if you've ever wondered about muzzle tuners and how they affect your barrel, you'll enjoy this podcast.
I'm Joyce Hornady. You might say accuracy is my business. I make bullets.
You are listening to the Hornady Podcast.
Thanks for joining us and enjoy the show.
Hello, everybody. Thanks for tuning in on this week's episode of the Hornady Podcast. I'm your host, Seth Siewert, and to my left, I have Senior Ballistician Jayden Quinlan. Across the table, Project Engineer Miles Neville, and special guest, author of Ammunition Demystified, been on the show many times, Jeff Siewert. Guys, thanks for coming on the show.
Yeah. Good to be here.
I think the audience for this show is going to be pretty excited. You know, when you look at our analytics, the episodes that get the most comments, the most likes, the most interaction, the most views, the most downloads, they're generally the most technically dense episodes that we have. And people seem to just love them. Anytime we can really dig deep into the science of ballistics, it's just fun, it's exciting, and people love to learn about it. And we've got another one of those today, although, well, I don't know. I was going to say this is going to be one of the more controversial episodes that we've recorded. However, if you look back at our past, there's been some that kind of put some ripples into effect on the internet, and that's okay. We're here to back it up. And before we devolve into small talk, I think we should dive right into it, and let's talk about muzzle tuners. Those things are relatively new in large scale. You know, we saw 0 of them, and then you go to a PRS match now, a lot of tuners going on. Mm-hmm. And I feel somewhat skeptical in some aspects of it, and I've never used one, never wanted to use one, and I'm excited to hear what you guys have found through your testing to really dive into muzzle tuners and what the efficacy is, and not just muzzle tuners, just anything that you strap that has a weight to it, any weight that you strap to the end of your muzzle. I'm excited to hear what you guys have to say about that. So how I would like to break this podcast up into kind of digestible chunks, let's talk a little bit from you guys about muzzle tuners, muzzle devices. And then Jeff, I want to hear from you on the testing that you've done on the simulation side, because I think that's really valid. One, to hear, okay, here's what this really sophisticated calculator says should happen. And then I'd like to shift gears into, okay, we've shot this a bunch, what actually happened, and to see if those two things line up. So muzzle tuners, I'm guessing they're not brand new, but we've certainly not seen their popularity rise until the last couple of years. But tell me what I don't know and what the listeners may not know about muzzle tuners.
Yeah, I mean, they've been around quite a while.
Oh, yeah, the concept is not new at all.
Yeah. Like there's even the old Browning Boss muzzle brakes were adjustable. You could, set screw those in and out. But the concept basically is that, and I've heard several, the I guess the most popular one is that basically you have add a mass to the end of the muzzle, to the end of the barrel, and that manipulates more or less the mode shape, the vibration, like the vibration pattern of the barrel to put, I've heard both ways, either a node or an anti-node at the muzzle, basically either to keep it from moving or to put it in the point that is
the same
pivoting, not moving,
motion,
but is pivoting. And the concepts vary from positive compensation to it damps down muzzle movement and produces less dispersion. I mean, that's the general.
Okay. So the goal of the tuner is to reduce dispersion.
Yeah, either to reduce dispersion wholesale and make smaller groups, or to positive compensate and tune for some vertical to get your vertical, your slow shots go high, your fast shots go low, and then they come back together at some determined range.
Allegedly.
With some percent efficiency, yeah.
Okay.
Well, the word tuner is important to break down too, because that insinuates that there's some sort of adjustment mechanism that's built into the thing to allow you to tune it, tuning meaning better or worse than, kind of a stronger or weaker signal, you could think of it as.
Okay.
And you see that with the majority of those devices, even the old ones. I think of if you've ever went to a gun shop and you see a rifle, laying up against the rack that's got some sort of like big black kind of rubbery thing.
Oh, the limb saver.
Right.
Yeah.
Well, that thing sitting on the barrel. Yeah.
Yeah.
I mean, that's an old method. And that one was to move up and down the barrel, and that rubber would help to damp any harmonics that occurred at a certain, position on the barrel. And then like you have the old Browning Boss, which was an adjustable muzzle brake. And then the more popular tuners that, you alluded to earlier that are kind of more tailored to the precision shooting world come in the form of something that you attach to the muzzle, generally by the muzzle threads, and it has some sort of adjustment of weight of the thing. Usually there's like a sleeve that is threaded, and it can move forward or backwards, which kind of changes the center of gravity, I guess, of the device itself attached to the barrel. So I think in discussing tuners, it's important to talk about that, because the other thing that we'll end up talking about is not only the efficacy of the adjustment of the tuning ability of the mechanism itself, but also the effect of it on and off, and which one is greater.
Oh, okay.
Yeah.
That sounds
I'd
good.
like to stick my 2 cents worth in here. Basically, what an added mass can do is one of 2 things. Either change the cross velocity or limit the pointing variability shot to shot to shot. The studies that I've done have said that, yeah, you can make a serious reduction in cross velocity.
Okay, define cross velocity.
So if the barrel is moving laterally as the shot exits, that's a cross velocity.
Okay.
Changing the pointing vector is a different thing. So that you're really changing the barrel movement is really changing where the bore center line is pointing.
Okay, and that's important, obviously.
That's yeah, and so the all of the analyses we've done over the years have said that basically, if you look at the cross velocity component of dispersion, there's 2 chunks. There's the angular rate chunk. There's the cross velocity chunk. The cross velocity chunk gets broken down into 2 bits. The first of which is that cross velocity that we talked about, the actual barrel movement, and the other is the pointing changing. And all of the analyses we've done over the years have said that the pointing changing is the bigger chunk by a large margin.
Okay.
Typically, the cross velocity component, about 80% of it is pointing changing, and only about 20% of it is the cross velocity component. And we'll talk a little more about that when we get into this.
Okay. So let's talk about the simulation before we talk about simulating muzzle tuners. The simulation itself is pretty damn refined. I mean, very, very, very dense.
Yeah.
Computational
So
power.
I'm gonna give you a little bit of history and tell you how where it's been used and how it's been used, and what assumptions I made to do the analytical part of this study. Basically, back in the mid-'70s, a guy who was a PhD in structural dynamics wrote a piece of code to help solve a development problem for the 30 millimeter GAU-8, the BGU-14, the API development. Wasn't going well. They took some flash x-rays of the projectile right at muzzle exit, and they caught the bullet with the penetrator dynamically deflected off the center line.
Mm.
And so this guy was like, oh, we can solve that problem. And he wrote a piece of code. And in the years since then, that code has been expanded to include the interaction with the barrel, a flexible bullet with a flexible barrel. It's been expanded to include muzzle velocity, pressure time curve variability, initial position of the projectile variability. It's been used on everything from 5.56 all the way up to 155.
Whoa, that's quite a range.
And so it's tank guns, it's medium cal guns, it's small cal. We've done several studies for small cal customers looking at the bullet barrel interaction over the years.
So it's proven that that one piece of code that now has been just really expanded on, and it's valid.
Yes, in the 50 years since it's been written, we've used it on about 50 different projects. So it gets pretty frequent use,
Mm-hmm.
and we're always looking at what the results say. Does this make sense? Does this track what we think is going to happen?
Mm-hmm.
And
then you test it with field results.
And you test it with field results. And one of the big problems that you run into with small cal is there are no built-in clearances. So, for medium cal, large cal, the bullets can't be an interference fit. For small cal, that's a different story. And as a result, you have to make some numbers, put some clearances in, see how does the analytical machine tell you how this thing is going to shoot. And sometimes you have to turn the knob a little bit.
Okay.
And what can it miss? Yeah, it can miss stuff like jacket deposition on the lands,
No way to quantify that.
No. Yeah. The other thing, we'll get into it, but does the jacket wear? Sure it does. Can I put that in the code? It turns out you can.
Oh.
Turns out you can. By fooling the program and telling it it's a difference in land diameter.
Oh, okay.
So I actually thought that up during deer season this year.
Slow deer season.
Yeah.
It was really slow, unfortunately.
Yeah. So it's a sophisticated program that has been flushed out and checked against actual field results, that it is an accurate program within, a couple percent, it sounds like.
When you have the correct inputs.
Okay.
When you have the correct inputs.
The Hornady Security Fireproof Keypad Safe. With a heavy-duty 16-gauge steel body, extra thick 8-gauge steel door, and 4 1-inch diameter locking lugs, the fireproof safe achieves a fire rating of 30 minutes for up to 1,400 degrees Fahrenheit. Both the interior and adjustable shelf are covered in a protective carpet that offers flexible storage configurations while safeguarding valuables from damage. The Fireproof Keypad Safe from Hornady Security.
So with the qualified program that helps with this really deep analytical stuff, when you apply muzzle tuner stuff to this program, what were some of the initial results that you were able to get?
So we evaluated a lot of different things. I'd like to talk a little bit about what the baseline is.
Okay.
And give people an idea, kind of what the analysis is based on.
Okay.
So what I simulated was a 24-inch long barrel, 30 caliber. It's kind of a sniper taper. It's
124.
1 point. That term's lost on me, unfortunately.
Okay.
But 1.18 inches at the back end, 3/4 of an inch, a little bit bigger at the muzzle end, and a linear taper in between.
Perfect.
I've got a diagram. Guys will have to put that up on.
Okay.
And also simulated a 1 pound muzzle device, muzzle weight. Okay, that's probably larger than most of the muzzle tuners that are out there. But I figured, let's do that and see what it tells us, and then we can certainly adjust the simulations from there.
Mm-hmm.
The code has capability to do a Monte Carlo draw for pressure time curve. Basically, we put in 7 different pressure time curves. There's a nominal, and then there's plus and minus 1, 2, and 3 standard deviations on pressure and muzzle velocity. And when the code does a Monte Carlo draw, it just interpolates between the 2 nearest ones. And so you've got the interaction between the change in velocity and inboard transit time with the barrel structure. So that's covered in there. The other thing that's covered in there is the initial position. And the way we set up the initial position was we said, okay, the bullet is perfectly made, but it's tipped in bore.
Okay.
Okay. And the tip can be in one plane, if you specify that plane orientation and a fairly narrow distribution around the clock, or it can be all the way around 360 degrees. So what we don't simulate is the bullet being, say, offset and then pointed someplace else.
Okay.
But that's one limitation of the code. But in all of the studies that we've done through the years, that doesn't seem to be a big limitation. And so for, say, bullets that have a cartridge case affixed to them, that seems to be a pretty good method to simulate the initial conditions.
Yeah. Okay.
Okay. For artillery projectiles that don't have a cartridge case, what we say is the thing lays on the bottom and there's a very narrow distribution of initial positions with regard to the bore center line. Like, okay. And that seems to work pretty well for that category of bullet as well. So provided you can define the system we're working in, I think we can do a pretty good job of estimating how the bullet starts in the barrel. And the simulation has told us that, gee whiz, if you've got 360 degrees and still just a narrow window of angle, you get larger than desired dispersion. So if you want to get dispersion that replicates what we see in testing, we have to really narrow the initial pointing vector of the bullet as it starts out and limit the variability in the initial tilt of the bullet with respect to the bore axis.
Yeah.
So a thing that we've used over the years called the jump equation. You're familiar with it. I'm sure you're familiar with it. No, he says.
No.
Okay, it's in the book.
It's ammunition demystified. It's in the book. Okay.
Yes.
Well, then I am familiar. But
Okay. So that equation does a really good job of predicting the dispersion for medium and large caliber bullets that are spin stabilized. Long rods out of a smoothbore, not so good, provided, not so much provided, but because there's no spin rate.
Mm-hmm.
Okay. So things that matter in the spin stabilized system don't matter quite so much for a fin stabilized bullet. Things like the inbore clearance between the ID of the barrel and the OD of the bullet, that's not such a big deal within a smoothbore system.
Okay.
Like, okay. In small cal, it's still applicable, but the inbore clearances are not so easy to define. So once you get to small cal dispersion, those dispersion numbers are smaller than medium and large cal by almost an order of magnitude. And certainly a factor of 5 or 8. So the sort of dispersion that we see with small cal systems is actually very, very good. And as a result, everything matters.
Mm-hmm.
So that's one of the reasons that the barrel tuners seem to be able to help in some instances. The numbers that I've made over the years in terms of what sort of group size do small cal systems shoot, what sort of drag variability do they shoot, what sort of inbore angle is evident in recovered bullets, then the inbore angles are pretty small, on the order of 0.03 to 0.04 degrees. Pretty
minute.
Pretty tiny, yeah. And so it's like, well, how can that have such a big effect? That inbore angle gets multiplied by the spin rate of the bullet, which is usually a pretty big number.
Mm-hmm.
And so that means that the initial angular rate, the disturbance of the bullet as it leaves the muzzle, can be fairly large. And so that's where the majority of the dispersion comes from for small cal systems, is the wobble of the bullet as it exits the tube.
Really? That's interesting to know. Unrelated to tuners at all, but that's interesting.
That is the largest source, and we did work for the military, and the best correlation was with the angular rate, with the yaw. The dispersion was most closely linked to the first max yaw. Okay, so one of the things that we did, there was a test that we did, I was involved with, that what we did was we took the bullets and we put them on a spin balancer. And so we measured the CG offset and the principal axis tilt of these bullets. And there was a couple of different assembly lines for the bullets, so there was things that were learned there. And then we took them and we fired them in a good barrel and in a less than good barrel. And we recovered the bullets and measured the length of the engraved sections. And we used that to compute the in-bore angle. At the same time, when we were doing that test, we flew the bullets through a series of flash X-ray. So we were able, and they're orthogonal, so they're perpendicular to one another and perpendicular to the flight of the bullet through them. And we were able to back into what's the first max yaw. And the first max yaw is directly relatable to what's the bullet angle at muzzle exit relative to the bore. So that's the thing driving the bus. That's what drives the disturbance. Okay. And so the angle that these things got to was actually smaller than we would have computed by looking at the recovered bullets. That's a bit of a head scratcher. To me, what that means is the bullet is oscillating in bore. Okay? And that's
getting some plastic deformation.
Elastic plastic.
Right.
Elastic plastic. So that's, from my perspective, that's evidence that the bullet can ballot in bore and can return to a position less than the maximum. So that is in fact balloting. There's one of the things we learned from that testing was the fact that, and again, military bullets, not lead core, copper jacketed match bullets. What we learned was that the as manufactured angles, principal axis tilt, was about a quarter of what we saw at muzzle exit. So what happens during the engraving process is more important, is a bigger swing than the manufacturing, which was a little surprising. Okay, so during the engraving or during the balloting, as the bullet interacts with a flexible gun tube, that's kind of the big deal.
Okay.
So
that's the lion's share of dispersion.
That's the lion's share of the dispersion.
Anecdotally, that kind of makes sense to some of the stuff we've seen, where we'll test bullets in the lab that shoot so, maybe not so good, and then we'll test them in different barrels, and sometimes they awesome.
They get better, yeah.
I can take bad bullets and put them. They're bad bullets out of this specific barrel, and take those bullets and put them in a totally different barrel, and they're now good bullets.
Yep. That's interesting. All right, so how can we transition now into taking what you just talked about and putting a muzzle tuner to it?
Right. So what I did was I took this analytical model and I put the 1 pound weight at the muzzle and I moved it. There's the model has a lump mass beam element model of the bullet and the barrel, and I just shifted the added mass at the muzzle in 10% increments between the last two nodes of the barrel. And these are nodes where mass is concentrated in the lumped mass beam element model. Again, we'll have to have you put images in there.
Yep, we can do that.
And So it's really for me, it's the view from like 50,000 feet. What happens when you incrementally move that 1 pound mass over the distance of those two nodes? And what I found was and I looked at 3 different barrel shapes, and I did a whole pile of testing with the variation in the initial position, both in terms of the angle and the angular or the rotational orientation. And you had to get pretty narrow on both of those to get it to replicate the sort of dispersion you see in the lab. So what I found was that I did a benign, what I called a benign barrel. It turned out it wasn't so benign, but it's just a half sine wave, a real smooth curve.
Okay.
It started at the chamber, and it went up to some maximum, and then back down to 0 at the muzzle.
So the bore not straight.
Bore is not straight, but it's not real crazy in terms of the bore centerline deviations. It's very smooth and repeatable.
And what you'd expect from a regular rifled barrel.
I wouldn't say that.
Okay, so this is a worst case?
This is no. It's just it's a benign non-zero case.
Okay.
Okay. Or what I thought was a benign non-zero case. And then I had 2 other bore profiles that I actually had data on from other measured sources, and I can't go into much there. But basically, one was kind of max bore deviation about half a thou.
Okay.
But it wandered in horizontal and vertical. And then another one that was a little bit more like 0.8, and that one was a little worse from a dispersion standpoint.
Okay, so the center line of the bore is just crooked.
Right. And I initially oriented everything so that the curves, the maximum part of the curve was in the vertical up direction. And the results I got were anytime you added mass to the muzzle of the gun, you increase the dispersion.
Mm.
I then said, okay, well, that's a little counterintuitive to what people are seeing. Let's flip this thing over. Let's take the worst case barrel and just change the sign on the bore centerline path definition and see if it improves. And lo and behold, it did.
Okay.
So from my perspective, the results of the analytical testing say that if you orient the barrel such that the addition of the muzzle mass, the muzzle tuner mass, makes the bore center line more straight or closer to straight,
mm-hmm.
you probably can make the group smaller. By a lot, 10%-ish was the kind of numbers that I came up with, 10, 12%. Okay. It wasn't a big swing.
But it was measurable in the analytics.
Well, and now let's talk a little bit about the numbers, okay? So I'll set up the run. I'll mash the run button, and 500 simulations of that bullet doing the Monte Carlo draw on the pressure time curve, Monte Carlo draw on the initial position, and the pointing angle. What it does is collect all of the angular rates and cross velocities at muzzle exit, and then mashes them all together and comes up with a dispersion number.
Okay.
And so that's the number that I've reported.
And that's a huge sample size if it's doing 500
yeah. So that's the other. I didn't get fooled by small sample sizes.
Right.
So that's basically the results that I got.
And it is common for a barrel to not have a perfectly true bore axis.
I would say in all of human history,
yeah,
a bore center line that is straight to 1/10,000th of an inch has never been made.
Okay. So every barrel's got some
crooked bore center line deviation.
And if you affix anything to the muzzle, a suppressor, a brake, a tuner, whatever, and that weight pulls that barrel back into a more straight line.
Something closer to straight seems to be beneficial.
Okay.
Now, I also took the benign bore shapes and flipped the signs on those, and I didn't always get smaller groups.
Okay.
So that's something I'm going to have to revisit
Yeah.
in the next few months.
So did those findings kind of align with your hypothesis before going into this?
Well, I don't know if I didn't have a dog in that fight. I mean, I don't make barrels. I don't make bullets. I don't make ammunition. I mean, like, I'm just curious, you know?
Yeah.
Yeah. And I did this on my own. Nobody paid me for this.
Hornady V-Match ammunition, loaded exclusively with Hornady ELD VT bullets. The low-drag design of the ELD VT bullets provide high velocity retention and minimal wind deflection. Initial offerings include 22 arc, 6 arc, 6mm Creedmoor, 6.5 Grendel, and 6.5 Creedmoor. Elevate your varmint shooting experience, shatter records, and make your mark like never before with V-Match ammunition from Hornady.
Right. So, guys, coming to you guys, hearing what Jeff just said as far as the analytics go, does that align with what you had in mind before you started your actual, live fire testing?
Yeah, I mean, we had Miles and myself had a lot of conversations, and Jacob and many of the guys, right, that are involved on the technical team, about the efficacy of tuners, because that's really what's in question, right? You're going to go, because we see this everywhere in the competitive shooting sports. Can I purchase a piece of gear that makes me perform better? Because if I can, then that's a shortcut to time and effort in training that will make you better, right?
Yeah. They should have like a precision rifle infomercial. You turn on the TV at 3:30 in the morning because you can't sleep in your hotel, and it's
bald guy.
The sham.
Says,
hey. It's the sham wow guy. Shrink your groups, get better, score higher.
So anyway,
and it's Bluetooth. You can just push a button and it works.
That's right. Yeah. We had a lot of conversations about what we thought from like a foundational standpoint the efficacy could or could not be, and I think we all came down to the agreement that adding weight to the end of the muzzle changes things. Like, we've observed that it fundamentally makes sense, both in theory, but also mechanical engineering wise.
Yeah.
So the real question is, does the adjustment of the tuner allow you to do something? Now, when we did our dispersion podcast, you said and you're going to have to help me again, the wacky arm.
Oh, inflatable wacky arm flailing tube man?
Yeah, so we had talked about in that podcast how that barrel can move, and there's a bunch of pressure behind the bullet, and there's some dynamic things that can occur, right? Barrel motion is a thing.
Absolutely.
And so that needs to be considered. And so the question was, well, if the barrel is moving and you can try to influence that movement, back to your point earlier of cross velocity, then you should be able to make things better. But the thing that we got hung up on, or I specifically did, was the mass of the tuners themselves that we see on the market and the amount of adjustment they have. How much does that actually change the way the mass sits on the muzzle? And my assumptions were that it's not enough.
Right.
Like, you got to make big steps to see differences.
And I agreed with that, as well as my take on it was that the variability shot to shot in just a pressure versus time curve was enough to, like, when you're talking, I'm going to move this 1,000th of an inch.
Or even 10,000. Most things are threaded 5H24, and 10,000ths of an inch of threads is...
Right. So if I'm going to make this tiny adjustment, and that's going to consistently, through 50 degrees of temperature swing and through the just shot-to-shot variation that you see on an even extremely well-made ammunition, like hand-loaded, top quality stuff. Like, there's going to be a couple thousand pounds of pressure difference between those.
Oh,
so,
absolutely. Yes.
Yeah. In the best case. That's the best case. So to say, I'm going to just totally tune this out so that it makes everything better, it's like, I don't know. It makes the presupposition that then every other one of the other variables that we mess around with dispersion is just okay and happy and benign to this thing that we're manipulating, and then this is tuning in that with this all checked out.
It's not a notch filter. It's not like you come up with the correct setting and all of a sudden the dispersion drops to zero.
Right. Yeah.
Consistently. That's I don't see that happening.
Yeah,
No.
so you have all this variability happening behind the tuner, right? Pressure time curve variability.
Principal axis
Principal
tilt,
axis tilt, center of
crooked
gravity
bores.
offset, balloting effects. All of this is happening prior to the tuner ever getting a vote in the as being part of the dispersion.
and the barrel pointing
right?
variability that we talked about.
So what we're saying is if the tuner works, then what it did somehow was correct all of those randomized errors that had happened before it. That's what the effect of a tuner would be.
And to play devil's advocate, I've watched people do this, especially on the interwebs, jump on the YouTubes. They shoot a 3-shot group, and it's 7/10. And then they make a 10,000ths adjustment, and now it's 3/10. They cut the groups in half.
Oh, we're
Jayden.
getting there. We're
Okay.
getting there. Yeah.
So I'm going to stick my 2 cents in one more time here. So to answer the question, does the addition of the weight on the muzzle affect the cross velocity? The answer is yes,
Okay.
absolutely. Does it affect the group size?
Maybe.
That depends on a lot of other things. But I want you to think about one thing. When you cram that bullet through the barrel with a bunch of pressure behind it, you have a big forcing function when it comes to moving the tube. True?
Mm-hmm.
So if you hang something on the end of the muzzle, where does that energy and that addition of that mass changes the cross velocity? Where does that energy go? It's got to go into the bullet. It's got to go into the bullet. And what's more elastic, the barrel or the bullet? I'm just asking the question. I'm going to let it. I'm not looking for an answer. I'm going to let that stay right there.
I couldn't give you one. True? Is it true or false?
I think the answer is C.
Yeah.
Beat me to it.
Yeah. Well, that's fascinating stuff.
Just a thought.
Yeah.
You know?
Yeah.
And I think before we get into the actual, live fire testing, I think one thing that is we could come as a conclusion this far into the podcast is hanging weight off the end of your muzzle will change things.
Mm-hmm.
Sometimes for the better, maybe for the worse, but it definitely does change things. And we're going back years ago now. Gosh, I might have still been working in engineering, but I walked up to Miles' desk and he's got textbooks open and something on his computer, and he's studying like resonance frequency for cantilevered beams. So you've been diving into this kind of stuff for years.
Glad you remember that.
Yeah, and it was over my head then. But the same conclusion. I mean, we might be going back 4 years now. Was like that frequency is a thing, and putting weight off something that's cantilevered will change things. No one is arguing that. And again, Jayden, you mentioned this. We have all experienced it. Everyone in the shooting world. If you put a pressure point in the end of your stock on your sport or contour barrel, if you put one of those rubber limb saver things on your barrel, if you put a muzzle device of any kind, suppressor, muzzle brake, whatever, you see point of impact shift, and you may have experienced greater or lesser groups, or you might not have, depending on how many things you shot. But we've all experienced that, so no one's arguing against that. And I think what I'm excited now to get into, and for the listener, I'm learning with you guys because now that I'm removed from anything technical, I work in marketing, nobody tells me anything. So I'm excited to see these results in real time because I have my own thoughts of how things work. But I'm excited to see this and hear your, again, large sample size testing, not 3 or 5 shot or even 10 shot groups, but actual valid group size with the inclusion of moving things to those settings that are usually laser engraved on the tuner, which seem to be every 10 thou or in some cases every thou, which is just minute adjustments in my opinion. I'm excited to see how that real life testing results that you're about to go over align with the balloting assessment that Jeff has done.
Sure. Well, so what we did is we got a couple tuners, and I did most of the testing on it. And my goal was to test it the way somebody would use it, the way a listener that's contemplating buying a tuner or they already have one, how are they going to use this thing?
The one that watched the infomercial by the bald guy that got suckered in with the Bluetooth tuner.
Yeah. So I installed it per the manufacturer's recommendation, and I picked 3 different rifles to test this with. One of them was a 6-arc. That was a Bighorn TL3 in a Manor stock with a Proof TL3 pre-fit steel barrel.
Yeah.
I chose a 6 Creedmoor in a Ruger precision rifle, so just a factory offering, very common. And then I did a 7-twist 5.56 bolt action barrel, and I shot some different ammo through that, which we'll get to here in a second. But starting with the 6-arc and the Ruger RPR. The 6-arc I tested, I believe it was the 108 ELD match load, and the Ruger RPR was the 108 ELD match in the 6 Creedmoor. And what I saw between those two was not big differences between the tuners. So I'm going to skip that data for a second, and we're going to go to the 223 data, because I did them in this order: 6-arc, 6 Creedmoor. And when I got done with those two, I really didn't see much, right? I had made adjustments to the tuner, and I didn't see much change in the dispersion. So I thought, in the most complex scientific wisdom I've ever read, that if you wash clean dishes, they're not going to get more clean. So maybe the dispersion is so good with these as they were that the tuner isn't going to improve it in an observable manner, right?
Okay.
So let's pick something worse. So I got 55 grain FMJ bulk ammo and shot it through this 7-twist 5.56 bolt action.
Good move.
It was much, much worse
Good.
than the other two. So we have the chance to improve things, right? If you're starting with a bad baseline, maybe you can improve it.
Yeah. Did you shoot baselines for the 6-arc and the 6 Creedmoor?
Yeah,
Okay.
absolutely. Yeah, so we'll get back to those. So this tuner, I did this 5.56 test with. Everything was suppressed with the test. Now what I did is I shot 3-shot groups, because people are going to do that. But I didn't just do one and then adjust the tuner. I shot a bunch of 3-shot groups at that tuner setting, then adjusted it and shot a bunch more. So on this first test I did of 3-shot groups, I tested 3 different tuner settings, and I made pretty big movements of the tuner's adjustment. Full revolutions is what they were in the indexing marks it had. Now, the 3-shot groups, as you would expect from the sample size podcasts we did, varied pretty widely.
Yeah, like 50 to 60% or
So
60
with,
to 70?
with tuner setting 0, so this was the baseline setter of the tuner, the average 3-shot group was 2.34 inches. This is at 300 yards. All this data is based on 300 yards.
Damn.
Conditions were really good. So we're not getting crazy winds and all these other influences, right? I did all this testing on a good day. So tuner setting 0, the average 3-shot group size was 2.34 inches. The maximum was 3.6. The minimum was 1.0. A lot of variation there, right?
I
could get anywhere from 3.5 to 1 inch 3-shot groups.
You put the 1-inch group on Instagram?
I did.
Yep.
On the account I don't have. So then I changed it to tuner setting 1, which was a full revolution change from the baseline of 0. The average group size was 2.5 across 1, 2, 3, 4, 5. 23-shot groups.
Wow. Okay.
Well, the average of tuner setting 0 was 2.34. This one's 2.5. So is it worse? Did I make it worse? I don't know.
1/8 of an inch worse.
Then I went another full revolution. So now I'm on a 3rd tuner setting. The average group size was 2.51. So across 3 different tuner settings, my average group size on 3-shotters really not that much different. Some may argue, well, that tuner setting 1 was smaller, so it's better. The point here is that the variability in a 3-shot group is anywhere from 1 to 4 inches. That's not stable enough to make a statement that one setting is better than the other. So we go to 5-shot groups. Well, with 5-shot groups, tuner setting 0 averaged 3 inches. It had a max and min of 2.6 and 3.9. Tuner setting 1, 3.2 inches. Min of 1.4, max of 6. Tuner setting 3, average 3.2. So all these averages are absolutely the same. 3.18, 3.21, 3.29. The variability, again, exists in a 5-shotter. We obviously know this. We did those podcasts about that. But that's what a shooter is going to be recommended to do. So I think at this point we have to address the fact that can you think you see an improvement with a tuner?
Of course.
100%. If I happen to shoot, if I do it by the way I did it, with tuner setting 0, my first 3-shot group was 3.09 inches. Well, that's not good enough, so I'm going to adjust the tuner. I adjust the tuner. the group went to 4.4 inches. Well, that's worse.
That's the wrong direction.
So I'm going to adjust it again. Then it went to 1.49 inches on the third setting.
Nailed it.
The tuner works. Leave it on that third setting and run. Things are better.
Mm-hmm.
However, the totals are identical. It's not repeatable. So that's in this specific test. If we go to the 6 arc and the 6 Creedmoor, with that testing, I did, with the 6 arc specifically, I did suppressed and unsuppressed tests of the tuner settings, and I did 20-shot groups.
Yeah, buddy.
I let it cool down. Like, you can rest assured I didn't allow outside influences to affect the results of the test. Tuner setting 0 with a suppressor, 0.85 inches. This is 0.85, inches. Unsuppressed, 0.87. So slight difference, suppressed to unsuppressed. Tuner setting number 1, 0.73 and 0.99 for suppressed, unsuppressed. Tuner setting 3, 0.77, 0.86. Tuner setting 4, 0.99, 1.15. So we see variability even in the 20-shotters, but it's substantially less. And it follows the trends that we've seen when we did those sample size podcasts where we said, if you shoot 20-shot groups, the expected variation sample to sample to sample, the same test is about plus or minus 10 to 15%. That's exactly what happened here. Across all those different tuner settings, the group sizes varied by plus or minus 15%. That's expected on a sample size of 20. You look at the 6 Creedmoor data. It was only shot suppressed, with one test being shot unsuppressed with a muzzle brake. So tuner setting 0, 0.9 inches. Tuner setting 1, 0.81. Setting 2, 0.89. Setting 3, 0.95. Setting 4, 1.0. Setting 4 was repeated by removing the suppressor, and it was 1.2. So we see a bigger shift going from suppressed to unsuppressed than we see across all of the tuner settings. This kind of goes back to supporting that, your analysis and also our assumptions that it seems to be more tied to the weight that's present,
the fact that it's there,
and not necessarily a minute change if there is adjustability in that weight. So across all this testing, I think because a user's going to have to make, or a listener's going to have to make their own decision on whether they want to use one of these or not, and whether it'll work or not. There may be instances where it works. This is a limited test, right? I tested 3 different rifles with 3 different loads of ammo. I think if you use the small sample size method, which is generally the recommendations that I've seen from the tuner suppliers, you might think it works, but it might not work. So it's up to you. If you want to play the small sample size game, you might get a result that seems like it works. And if you want to go with that, cool. We're not saying you're right or wrong. You do whatever you want. It's America. It's a free country. I don't care what you do.
It's a free rifle.
However, in a professional capacity, we can't make decisions based on that method, right? We're running a business. There's consequences from doing stuff from that standpoint. So we have to do it in a statistically valid of a way as we can. Ultimately, you would shoot all the shots possible out of every rifle in every tuner setting, and then you would have the actual answer, right? But we can't do that, so we're just kind of dipping our toe in. But the test data that we have shows that across those 3 tests, the tuner did not make changes to the result outside of what would be expected just from test to test to test of that sample size of result. The changes that we did observe that may be outside of that result were tied to the addition or removal of large weight objects, mainly a suppressor.
Mm-hmm.
Large weight in ratio to the weight of the tuner itself is what I mean by that statement.
Interesting.
So I guess at that point I would throw it over to Miles, because you've done some other testing, with the weight stuff, and I think that'd be a good time to cover that.
Yeah. So this goes back to trying to make gas gun work for PRS.
Do you recommend that?
No. Yeah. It's a challenge. Yeah, and that's a separate.
Yeah. Well, what were some of the challenges that you were facing that led you to, hey, how can I make this better?
Okay, so gas gun is very picky in how you put the pieces together on the rifle. It's a lot more flimsy system, like aluminum receivers, I think, in general, and then you're putting the bipod, your connection to the ground, basically, whether a shooting bag or a bipod, is directly to a forearm that then directly to the upper right where it holds your barrel. And so Basically, if anything in there gets bound up, if your gas tube binds and is pressing against the upper, like you can see erratic flyers show up. If your gas setting is changed, you can see more erratic flyers show up. There's a whole litany of things that basically found on accident, but the main one as it pertains to this was that I had worked up a load with a 4-port muzzle brake, PRS, style muzzle brake, with 108 grain ELD match bullets. Had to go to a match that was suppressor only. Like, okay, no big deal. I've got suppressors, so I throw suppressor on the rifle and I shoot it, and that same load that was easily sub-minute of angle for 20 shots, like in that ballpark of like, okay, I'm happy with how this is shooting. Finally, I feel like I can take this to a PRS match and not have the rifle be the limitation.
Mm-hmm.
That then turned into like a 2.5 minute system as soon as I went from muzzle brake to suppressor. So sanity check, put the muzzle brake back on, back to being a 1 minute of angle system. Like, okay, well, that does me no good because I have to have a suppressor for this match, right? So I put the suppressor back on and then go dinking around trying different bullets because I have a powder that I want to use. So I go back and try different bullets. So going through different bullets, I find that I can take the same powder, same cases, almost the same charge weight with a 110 grain A-tip, and now I'm back into that sub-minute of angle category. And then just for fun, I throw the muzzle brake back on, and now that's like 1.75 to 2 minutes. And so then I get like real curious and go down in the lab and took basically every suppressor I own and every compatible muzzle brake that I own and shot them all for 20 shots with a fixed, ammunition type.
Mm-hmm.
And then weighed all of those and then got some collar shafts to put like right behind the muzzle device basically, and then modified a couple of collar shafts and got them all so that whatever combination of whatever I put on there weighed pretty close. Pretty close. I mean, not exactly, but pretty close. And then shot all of those different muzzle devices just as they were, and then shot them all corrected weight to the heaviest one. And the dispersion basically from whatever it was to corrected with weight did not change meaningfully. It was basically the same. So the addition of just the weight, now it did move point of impact.
Sure.
Definitely saw a point of impact shift.
Yep.
And then so I took then the lightest one, which was the muzzle brake that I had started with, and then just did a stepping of shaft collars on the barrel. Just put more and more and more and more. I think I ended up with up to 4 or 5 of them on there. So, and that dispersion wise, no change whatsoever through all of those steps. But then you could see like you could see, that it actually went down and then it started to come back up with the 4th one. And I didn't think to look for point of impact shift at the time. So I retrospectively went back and was plotting it all out. And it's definitely something I'd like to investigate a little bit further going forward. But yeah, it was just interesting. But the dispersion as it related to muzzle devices was distinct and repeatable, but didn't really seem to be affected so much by the mass of it.
It's
more
just the fact that there was mass.
Something else within the muzzle brakes and suppressors was causing that. So I tend to think muzzle exit gas flow maybe outweighs whatever benefit or whatever that you're getting from having the mass there. And that kind of goes back to like when I said like to just validate a tuner assumes that every other thing in the list is kosher, and we're just looking at the tuner, and
that's hard to do.
It's hard to do that because there's other things that you can mess with while you try to poke at one thing. It's really, really hard to just poke one thing.
Yeah, agreed.
The Hornady Click Adjust Bullet Seating Micrometer. Precisely set bullet seating depth with Click Adjust in 1/1000th of an inch increments and easy to read graduations. It's a quick and easy way to achieve bench rest accuracy and consistency with tactile clicks just like a Click Adjust scope turret. Easily installed on Hornady custom or match grade seating dies. Take your reloading game to the next level with the Hornady Click Adjust Bullet Seating Micrometer.
Well, let's assume that you have a bolt gun in a universal receiver and you can just poke one thing. Jeff, I think you did some work as far as how many shots it takes for it to make a 95% correct, or like,
Yeah. So for a 25% difference in true dispersion. Now, 25%, in my book's a big swing.
huge.
That's 3/4 minute to a minute.
Yeah. Takes you 40 shots, 20 controls, and 20 new items for a 25% difference at 90% confidence level. So you're wrong 1 time out of 10. If you want to bump that to 95% confidence level, it takes you 60 shots. You willing to spend that sort of resources to prove that change?
Some people probably are.
Some people
Yeah.
probably are, and they should.
Yeah, if you're going to do it, you should.
Absolutely.
Yep.
Absolutely.
Now, is there something we talked about, whether it be a tuner or any sort of muzzle device, if you put it on there and it just happens to pull your bore center line closer to straight, then you reasonably will see a reduction in dispersion. Are people doing that in the gunsmithing world where they'll use some sort of indicator rod to find out, okay, where their center line lies, and then chamber it such that is...
You're measuring the curve of a highway off of the start point and end point, though.
Okay.
There's nobody that live on the...
That's a good way to put it.
Yeah.
That's a really good way to put
There's
it.
no way that I'm aware of that anybody is realistically wholesale doing to...
They might talk about it, but you're only doing your indicators on
I mean,
one
like,
end.
I'm holding it here, and I'm even the guys that got the fancy chucks that can adjust angle and position here, and then they measure where that time's up, and then they'll try to time so that the highest point of the muzzle is at 12 o'clock. That probably does get the muzzle at 12 o'clock, but then everything in between here and there, who knows?
No control over it.
No way to know.
So there's no way to know when you put that muzzle device on if it is pulling your true bore axis.
Unless you have, and maybe this is kind of moves the state of the art forward here. Unless you measure the bore center line prior, and the muzzle and the barrel maker stamps it with, put this end up.
Yeah.
When you clock it and made it up to the receiver.
Yeah.
I don't know anybody that's doing that.
No, that seems pretty advanced. And
the only thing I've seen done is I know Gordy Gritters used to index it so that if there was run out at the muzzle, it would be oriented up, and the purpose for that was to maintain more adjustability in the optic. So essentially, let's say if you indexed it muzzle down, then when you zeroed your rifle, you'd have to come up an extra half revolution to get it zeroed. Vice, when he would index it muzzle up, you gained a half revolution, say, just for general purpose. That's the only intention that I've seen people do that actually had a result that meant something.
Mm-hmm.
So I'd love to see what Jeff's talking about. That would be really cool.
I have seen laser measurement devices for small cal barrels. They basically position the barrel vertically, and they've got a long probe that goes down through the muzzle of the gun towards the chamber, and it maps the center line. And it's been a long time since I've looked at those. I can't tell you what the resolution is. It's got to be under 1 thou, or it's not worth doing.
Right. Yeah. I think we've got some friends in the industry that have one, and it's several tenths.
And the machinery is enormously expensive.
Yeah.
Mm-hmm.
Or down to the 10th, rather.
Yeah.
I need to make a correction. I just realized when I was talking about all those different data points on the test, that was all mean radius data.
Mean radius data.
Yeah.
Okay.
So that's mean radius at 300 yards.
Yeah, which for the listener, if you haven't, go check out the Mean Radius podcast.
Yeah.
That's something that you guys are using in the technical side of what we do at Hornady to assess things that's more useful than just extreme spread of group size.
Yeah.
Yeah, so go check that one out if you haven't.
I'd like to say that I have on my website a paper on muzzle tuner madness.
Okay, what's the website?
Bulletology.com.
Bulletology.com. Go check it out. And
it explains in considerably more detail the sort of work that I did here.
okay.
And I think just from our discussion here, I've got a few more things that I've got to go look at.
Yeah.
And as I learn things, I'll be adding to that.
Yeah. Well, and as you learn things, we're going to keep continuing to get you on the podcast as long as you keep coming through Nebraska.
Okay.
Because it's does us a world of good internally, and for our consumer, the really advanced hobbyist, the advanced technical hobbyist. This is what makes the world go around for a lot of us, is understanding what's going on and really, a student of external ballistics and precision shooting. And this is always a pleasure to hear this kind of stuff, and one, to see the advanced computational power that you have access to with that balloting program, and then to see it juxtaposed against these guys who are just down in the lab shooting stuff, but to see how they really align well. And it's neat to have access to you and to that program.
Happy to help out.
Another thing I wanted to say was, there's going to be a lot of comments about this subject and topic because there has always been, right? I mean, I think Miles tipped us off the other day in the lab to some forum thread or something where it was like
getting heated.
Violent. Yeah, it was crazy. But I don't want to discount anybody's experience because that's valid too, right?
Yeah.
However, I have not seen a statistically valid data set that supports them.
The tuner settings.
Yes, yeah. That makes it plainly evident that yes, that one adjustment with everything else being kept a constant had this net result. Everything that I've seen, everybody that I've talked to, it's all based on the smaller sample size stuff. And that's fine. Again, like if that's the route you want to take, it's understandable, right?
Yeah.
Ammo and time are expensive. Barrels are expensive. But if you ask me, should you get one or not, I'm not going to give you a yes or no answer. You gotta determine that on your own. But I will tell you, in my testing, I haven't observed a difference, and I have also not been presented with independent data that counteracts that.
Understood.
So additionally, we kind of poked around with some folks that we know that have pretty cool test facilities, and they have also not really seen anything.
Yeah, big test facilities, bigger than what we've got here.
Huge.
Yeah.
The ones that have done the research that has defined our understanding of modern ballistics.
Yeah. Okay. Well, that's saying something then. And, again, we've said it all, but to kind of bring everything back to another conclusion here towards the end of the podcast, hanging stuff off the end of the barrel changes certainly point of impact, and it can change dispersion. The individual settings of a tuner, we've not been able to document or predict with the analytical equipment we have that it's going to do anything in those small revolutions. It's the physical mass hanging off the barrel that, if it's going to do something, that's what it's going to be.
Yeah, I would say that's a fair assessment of what we've observed.
And again, as with everything where we say stuff, we haven't tested literally every combination.
Yeah. We know what we know. We've tested what we've tested, but we don't know everything. We haven't tested everything.
Right. Yeah. It's within the limitations of what we've seen.
And how many bullets did you guys expend on this test?
Well, let's see.
Give me a ballpark.
For 6-arc, I did 4 different tuner settings, suppressed and unsuppressed, 20 shots apiece. And then I did no tuner suppressed and bare muzzle. So that would be 10. So I did 200 rounds of 6-arc. I did 120 rounds of 6 Creedmoor, and then about 300 something rounds of 5.56.
Jeepers.
I was in it probably about 200 rounds with my rifle.
So you've got 700-800 rounds expelled to get to the conclusion of we've shot nearly 1,000 rounds, and you can hang stuff on a barrel and it makes a difference, maybe, but the individual settings don't make the difference.
Not from what we saw.
Yeah.
And analytically, I'm like way north of 30,000.
30,000. And like we talked about at the beginning, the analytical assessments really line up quite well with actual field
Yeah,
results.
so kind of the thing we would want to do next would be to find a barrel that's been measured carefully, clocked,
Mm-hmm.
put it in a receiver and shoot it and see if we shoot it with that orientation, it shoots better than if we rotate it 180 degrees.
Right.
That's what we'd want to do.
Wow. Well, that's pretty crazy. And then when you mentioned time and money. So obviously that was your guys' time, and you guys get paid to do this R&D stuff. Jeff, you're retired now, so I guess I
want to know the answer.
Yeah, but as far as in the lab shooting, there's the time aspect to that. But if you shot nearly 800 rounds, and if you went to the store and bought 800 rounds of match ammunition or even that bulk stuff, you're going to be $1 a round, let's say,
Right, yeah.
or some of this stuff, sometimes more than that. Well, gosh, yeah. I mean,
It's 2023.
Yeah, ammunition market
Well,
fluctuates
2024
quite a bit.
soon.
Do you guys remember when 6.5 Creedmoor match ammo used to be $20 a box?
Yeah.
It's crazy. So my point, though, is that there's a monetary value associated with this if the user, the listener out there, wanted to really put the pencil to the paper and find out with some statistical significance what their results were.
Mhm.
I mean, it's hundreds of dollars of investment, or north of $1,000 in some cases, depending on what you're shooting.
Yeah.
And that
And-
means something.
And there's going to be some anecdotal points brought up of, well, I see these guys using tuners in competitive natures, and they perform really well.
Damn right.
I'm gonna name drop Mr. Cortina here. I really like Eric. He's an awesome dude. We've had some good conversations,
Mhm.
some contentious ones too.
Yeah, well, they've been
but-
really good to listen to, and
Yeah,
tangential.
he-
You guys, listeners, should
so
do that.
By no means through this conversation am I trying to downgrade Eric or anything along those lines. But a lot of people will point to Eric and say, well, if tuners don't work, then how come Eric performs as well as he does?
Because he's a high performer.
He's really good. I mean, his track record shows it. And I think two things. One, he's using really good components across everything, including and the tuner's thrown in there with that, right?
Mhm.
But his bullets are good, his powder is good, his loads are good, his cases are good, his barrel's good, his action's good. All that is
Yeah.
good.
Gunsmithing is good.
That's going to bias you towards good performance.
Yeah, it's like I've been saying it since we started podcasting. You build a race car with race car parts, you end up with a race car.
Yeah. And now the other part, though, that I think is valid that we don't think about a lot is, let's say I'm just the average guy, and I look at that guy that's using the tuner that performs really well, and I've got it in my mind that they work, and if I buy one, it will make me better. That I have a biased position to that idea. I buy the tuner, I put it on the rifle, and I do this exact test here. Tuner setting 1 shot a 3-incher, tuner setting 2 was 4, and then tuner setting 3 was 1.5.
Yeah,
Found
buddy.
it. I leave the tuner there, and I go shoot competition. That process built in confidence, right? I had a bias. I confirmed the bias by the use of the tool. It produced a better result from the simple observance there. And I took that result and I ran with it. I've seen over and over in competitions, whether it's shooting or just any competition at all,
Sports in general.
the level of your baseline confidence going into that competition can and usually will have an effect on the performance.
Yeah, I've been a huge fan of placebo effect my whole life. But, in the sports science thing and supplements and now in shooting, if my mind tricks itself into performing better, great.
Absolutely.
I don't care if the supplement worked or not. If I got the benefit of it, whether it worked or not, because my mind is tricking itself, thumbs up. It still worked.
Yeah.
And same thing here.
There's several top, really, really good PRS shooters that we've talked to and tried to tell them about sample size, and they don't
want to hear it.
They want to hear it. They're
Because
like,
they
you might be right. I don't care. I want to know my rifle's a laser beam.
Yeah, I want to assume every time I pull the trigger, it shoots the same bullet on top of the same bullet on top of the same bullet, one hole at every distance, and then they never have to question their equipment.
Right.
And if they miss, it's the nut behind the bolt. There's a bunch of sports psychology stuff there, as far as getting into the zone for competitive stuff, and they want to assume their equipment shoots one hole. And you're exactly right. They said, statistically significant means nothing to me. I don't care. I want to assume I put every bullet in the same hole, or the rifle system puts
Right.
every bullet in the same hole every time.
Yep.
And again, if you need that level of confidence to perform at a high level, great.
Yeah.
But we don't want you to be blinded by the lack of science.
Right.
See what I did there?
I did.
So, is there anything else in the world of tuners or tuning that we didn't talk about or that you want to cover before we wrap this thing up?
Yeah, the only other thing was like at the beginning I mentioned positive compensation.
Yeah, let's talk about that.
Have still not yet hit it. There's a couple tests that I'd like to do. I'm going to probably end up machining. The other thing too is the muzzle exit gas flow. I'm probably going to end up making some muzzle devices to poke around at that.
Yeah.
And see what we can find there.
Yeah. Do you think it's a drag thing or?
I don't know.
Interesting.
Yeah.
Have Doppler will test.
So that concept comes from, let's say, the suppressed to unsuppressed difference you see. Okay, you're definitely adding and taking weight off. We know that that's definitely happening. But you're also changing the flow of those gases before the bullet completely escapes and distances itself from them where they can have no force effect on the projectile. So with the suppressor test, how do you know which one's doing what? Is it the weight that changed the dispersion, or is it the change in the muzzle gases as the bullet uncorks?
And so like I guess going back to my test that I did where I tried to match weight very closely and the distinct dispersion characteristic was tied to the muzzle device. Yeah, I'd like to poke around on that a little bit more.
Yeah. Well, let it be known, listeners out there, we're continuing to test. And I say we like I'm doing anything, but you guys are continuing to test the stuff that we want to know and that likely the listener wants to know. It's not like you're out there trying to discredit anything. You're trying to find out, is there something I can do to give me the competitive advantage? And that benefits everybody when you take those test results and get them to, the masses via podcast or going to the matches and talking to folks.
Yeah.
So, yeah, let that be known that you are always testing, and that's much appreciated.
Yeah. Give special guest the last word.
Probably. Jeff, thanks for coming on the show for sure. We always love having you.
Thanks for having me again. I really appreciate it. And let's see if we can't do a repeat.
Yeah.
On the way back through.
Yeah.
Hey, that sounds good. Is there anything else as far as muzzle tuners or tuning that you wanted to leave the listeners with?
The tuner can affect the cross velocity in terms of the motion of the barrel, but it can't affect the pointing.
And as we talked
the pointing
about,
variability, and it's really the pointing variability that we worry about.
Mm-hmm.
So that's, like I said, the split is about 80% pointing variability, 25% cross velocity. You can make a small effect on the cross velocity, but I think a big swing is
needed.
Is really tough.
Yeah. Is there any way to help the pointing variability?
Buy straighter barrels.
Fair enough.
Yeah.
Will do. Let me put that. Yeah. Next time I order a barrel, I'll put that on my order form. Send me a straight one. Jayden, anything else on tuning?
No, it'll be interesting to see how this is received. Again, we're slightly privy to some of the conversations that happen out there, and this is a contentious one. So
it is.
Can't hardly wait.
I've got a lot of very close friends that swear by tuners, and I'm not going to distance myself in our friendship because of that. I got no problem with it. We're just telling you what we found.
Yep, exactly right. We're not telling you what to do. We're telling you what we found.
Yeah,
exactly. Good way to put it. Guys, anything else? Nothing? All right.
Good.
Thanks for coming on the podcast. Jeff, especially, you really appreciate working us in. And guys, I know you're super busy in the lab all the time. So again, thank you.
You bet.
Mm-hmm. Absolutely.
Guys, hopefully you enjoyed this podcast about muzzle tuners and tuning a barrel. We'd love to hear what you have to say. This is what we found. But if you've experienced what we've experienced, or if you've experienced the exact opposite, drop us a comment here. We'd love to hear about it, or email us at podcast@hornady.com. And again, a special thanks to Jeff Siewert, our guest today. Check him out on his website at bulletology.com and his book, which is available on Amazon. That's Ammunition Demystified, the non-Bubba's Guide to How Ammo Really Works. We hope you enjoyed it. We'll catch you on the next one.